Hi guys, this video is gonna be the last video on section 9.1. So here in this video, I'm gonna go over length of a space curve. So if you're given a vector function, like here in the where you have three components as a form of a function, so what you do to find its arc length is, okay, so there's a formula to find it. So suppose you're given this vector function, okay, f of t I hat and g of t j hat plus h of t k hat. And to find the arc length, what you do first is you're going to take the derivative of each component. So derivative of each component, k and h prime of t k hat. Okay, so f prime of t, g prime of t, and h prime of t, taking the derivative of each component. And then you remember taking the magnitude. So yeah, like you're gonna take the magnitude of this vector function. Okay, so first of all we take the derivative, and then we're gonna take the magnitude of the function. Okay, so how do we do that? So we're gonna square each component. Okay, and g prime of t square, and then square root the whole thing. And at the end, what we're gonna do to find because we're finding the length, okay, length of a space curve, so it's gonna be between intervals. So you're gonna integrate from like a to b, the interval that you're given, like the length that you're trying to find in the interval. So you're gonna take those intervals and put them in here, and you're gonna integrate this function with respect to the interval. So here, so taking the derivative first of the function, and then taking the magnitude, like squaring each component, and then square rooting the whole component, and after that taking the integral of the function. So this gives us the arc length. Okay, so now let's do a problem. Okay guys, here we have a problem where we have to find the arc length. But like before we do this problem, let me just simplify this formula for you because it looks kind of ugly right now. So it's just a better way of writing it. You can write this way as well if you want, but let me show you another way. Okay, so what did we do first? We had r of t given. Okay, so what did we do? We took derivative of it. Okay, so taking the derivative of the rt function, and then taking the magnitude of it. Okay, so magnitude it, and then at the end integrated from a to b. So it is the interval given. Okay, so this is simply the formula. So you can memorize it this way or this way, whichever you want. It's gonna give you the same thing, but I find like this way, writing it this way, it looks much neater. Okay, now let's do this problem. And like before we do this problem, by the way, I have already showed you how to graph this function in my previous videos. If you want, I'm gonna provide you the link of this video in the description below, so you can watch to how to graph this function. Okay, so for those of you who are interested to find how to graph this function, so here I made a video on this. So I'm gonna post the link of this video in the description below. Here I give a step-by-step solution of how to graph this function. So it's gonna look like this at the end. And if you want a better picture, so this is how it's gonna look like. So do watch this if you're interested. Okay, now guys, let's finally solve this problem. So here we're given the formula, and here it says first to find the derivative of the function. So first of all, we're gonna find the derivative of the function, so which gives us, we're gonna do component by component. Okay, so the first component is 2 cos t. So finding the derivative of that, for that, let's do an aside here just so you guys recall the derivatives of cos and sines. So what's the derivative of sine x? It's cos x. And what's the derivative of cos x? It's negative sine x, okay? So just remember this, and it's gonna be a piece of cake to find the derivative, okay? Now, let's come back to the problem. So it's 2 cos t I hat. Okay, so the derivative of 2 cos t. What's the derivative of cos t? It's negative sine t. Okay, and 2 is just a constant, so it's just going to stay in there. So negative 2 sine t I hat plus, and then now moving on to the second component, it says 2 sine t. And what's the derivative of sine t? Yeah, it's cos t. So the constant stays there, and 2 cos t. And the derivative of now tk, and derivative of t is just 1 because it's a variable and we don't write 1, so just gonna write k. Okay, and yeah, here I forgot j. um okay, j plus k. Okay, now what's the next step? Here it says to find the magnitude. Now how do we find the magnitude? We square each component and then square root the whole thing. Okay, so squaring each component give us, okay, so negative 2 sine t squared. By the way, square of negative is just gonna be positive, so if you wanna write it here or not, it doesn't matter. Okay, so 2 cos t squared plus 1 squared, and then square root the whole thing. Okay, now this gives us 4 sine squared t plus 4 cos squared t plus 1. Okay, now if you see this, do you remember an identity to replace this with? Okay, so if you don't remember, let me recall, okay? So sine squared of x plus cos squared of x is equals to 1. So this is a trig identity that you need to remember. So here with this identity, if we factor out a 4 here, we can replace this by 1, okay? So here, if we factor out the 4, so here we have sine squared of t plus cos squared of t plus 1. By the way, it's the same thing, x and t, it's just variables, so it doesn't matter, okay? So don't confuse yourself with that. Okay, now replacing this with the trig identity, this leaves us with 1. So we have 4 times 1 plus 1. This leads to 5, okay? And then remember the square root, don't forget it, okay? So just keep writing it until the last step, and here. So this is what this gives us after doing this thing, okay? But we're still not done. We need to integrate it from the from a to b and from our interval. Okay, and what is the interval in this case? So here it's saying greater than equal to t is greater than equal to 0, so our interval is from 0 to t. Okay, so this is our interval 0 to 2 and then square root of 5. So this is what we are looking for. Okay, now let's do this on another page since I don't have any space now. Okay guys, so here the variable is t, so we will integrate it with respect to the variable which is t, so we put the t. Now integrating it gives us square root of 5t. T because this is the variable, and since it was a constant, so we put the variable in front. It's integration, so we have to put the variable in front. It's the constant will not be 0, that's only for derivatives. Okay, now plugging in the values simply, so 5t minus 5 0. So here the t just replaced with the t, it doesn't matter. So here this leads to 0, so the answer just simply becomes 5t, square root of 5t. So this is the answer. This is the arc length of the vector field. Sorry, the vector function, the function traced by the curve. Okay, so if you want to do a numerical problem, like not with the intervals of the variables, like numbers, so let's do that now.